Thanks for joining us tonight. Look, by way of introduction, what I'm going to do, I'm going to stop sharing my screen, and only because I wanted to show you a few things live, just to set a bit of a scene for everybody. What I want to do is, look, I'm really pleased to be able to tell you about this new course that Monash Science is introducing, a Master of Green and Sustainable Technologies. What's it about? Well, it's really a green chemistry course, but just to kind of help you through this and setting a scene, I want you just to think about everything in our lives around us and the lifestyles we've become so accustomed to. I've got my mobile phone over there on the charger, and if you think of the mobile phone and all the components that are in that, something we just take for granted, and you know, some people believe they can hardly live without one. I think I could live without one, but if we just look around us and everything we've got, and here's, you know, food, Vegemite. I don't know whether you're a Vegemite fan, but if you think of our food, you think of the things we take for granted in our diets, other things in our lives. Here's some what do you call it? It's a aftershave. Very nice lemon one that I found that I like. You can't get it in Australia, unfortunately. Cleaning agents. Okay, I'm using toothpaste as an example, but you can pick any number, your detergents, your soaps. Here's another. These, I just grabbed these out of from around the house. Deodorants, all the therapeutic agents, our medicines. Okay, this is an over-the-counter, just a headache or pain suppressant, but there's all the ones that we get under prescription. There's all the work going on under COVID. Things we don't think about, trivial things like paper and printing, dyes, colours. You can see my background here in the room. There's paint on the walls, there's furniture, there's adhesives holding furniture together, there's pictures that hold things together. All the materials around us, and that includes food. I mention food because the things we need to grow our food and produce our food, the agrochemicals, the fertilisers, all those items, if you think about it, have come from some sort of chemical manufacturing. And maybe you haven't thought of chemistry in this broader sense, but that's what chemistry has contributed to our lives. And of course, as we know, and often the bits that we hear about chemistry that get in the public arena are the negative things, when something's gone wrong, when there's a spill or something toxic has got out and caused some harm. We never talk about or hear about all the great things that chemical manufacturing's done for our lifestyles and what we've become accustomed to. The other thing is that we know through manufacturing, and manufacturing means that we've needed to use energy, we've needed raw materials, all the material things we need to produce those items. I just picked a very small set of examples. All those things have had an impact and associated with our climate change issues, because the energy has come from fossil fuels. Population has grown as a result of the prosperity that humans have been able to enjoy on our planet as a dominant species we are. So we're also dealing with the climate change issues. But what I'm trying to get at it is, if we start thinking about how do we manufacture things, how do we get all these things, how do we use the energy, we potentially can start thinking about how do we not have problems. So that's what green chemistry is all about. So I'm going to go back now to share my presentation, and I hope this is working. Let me just check that. Sorry about this. I could be a bit, this should work, I hope. And Kim can tell me if I'm not sharing a screen. I think I'm okay. Yep. And I'll go to slideshow mode. So that's, I hope you can all see that. All good?
Perfect.
I'm assuming, okay. All right, great. So I already, if you like, I've just got some more images here, but just to reiterate, reinforce what I said, chemistry has a great role in everyday life for everybody on the planet. And whether we're talking about developed countries are trying to improve, and they have an opportunity, if you like, to think about implementing green chemistry principles from the beginning and not making the mistakes that we've made in more developed countries by having problems. So I'm assuming, I'm not sure your backgrounds, and maybe you can tell me through chat or we can talk about it afterwards. But I'm assuming some of you have done a little bit of chemistry, or at least are interested in it. That's why you're here tonight. But what is green chemistry? It's about designing products and processes that eliminate hazardous substances. We try and use renewable feedstocks. We try and use minimum energy. Life cycle thinking and circular economy, they're terms you hear bandied around nowadays. And all this is linked to sustainability. And one of the things we deliberately put in the title of the course, you might have noticed we called it green and sustainable. And there's a reason for that, because everything that is green is not necessarily sustainable. So green is about the key principles that are outlined on the slide you can see in front of you. But sometimes things that are sustainable are not green. They can be, for example, very toxic. And we have to be careful how we use the terminology, but we have deliberately said it's got to be green and sustainable in terms of the thinking we're trying to develop and the training we hope that a course like this will give you as you go through. The other thing, and I know you've all undoubtedly come across the UN Sustainable Development Goals. When we think about all these materials and the processes that we need, one, to enjoy the lifestyles we're used to, but also to alleviate poverty, to ensure, you know, this food security, prosperity, health, water sanitation, all those issues that the UN Sustainable Development Goals address. These are things that chemistry will have a very big role in solving. Now, some people cynically will say, but chemistry created the problems. Perhaps in some cases, definitely, that's undeniable. But with the green chemistry thinking, we can avoid the problems. The whole idea is don't have a problem. And these are the, again, coming back to the issue of what our new course is going to address. So why would you want to choose it at Monash? Well, we believe at the moment, this is the first course like this in the Southern Hemisphere. Not to say that in the future others mightn't come on board, but certainly in Australia, no one else is offering a course around chemistry with this focus. Of course, Monash is #1 chemistry school in the country, and we're ranked certainly in the top 100 in world rankings in chemistry around the world. So we fight pretty well in terms of our weight. This course is also going to have a very strong, well, industry and, if you like, application focus around it. So we're hoping that as a graduate of this course, whether you've done a little bit of chemistry or a chemistry major, you'll be oriented a lot more to being able to work in industry, but not exclusively. It doesn't stop people from pursuing other careers. And they're not necessarily jobs, and we'll come back to the job issue. There's lots of opportunities for jobs in this area, and it's not necessarily being in a lab, which sometimes is a misconception of people who've done a chemistry major, that they're going to end up working in a lab. In fact, the reality is that most chemistry graduates, very few, spend a significant part of their working career in labs unless they want to and like doing that. Monash's facilities were definitely state-of-the-art. The image you see in the background is our new Green Chemical Futures building, we call it. It's part of the School of Chemistry, but there's also some industry bodies that work in there, and we have some shared facilities with some of the other faculty, engineering in particular. And the partnerships of this course as well, we do share quite a bit of the offerings with engineering and business and arts faculty as well, but we can talk about the elective stuff later. So I've already mentioned some of these things on this next slide, that green chemistry can have a significant role in UN Sustainable Development Goals. We'll be hoping that through people doing this course, you develop knowledge and skills and leadership, potential that will help transform the chemical industry of the future, and address very much the green chemistry principles. I mentioned there things like internships, an opportunity in this course. There's also research project opportunities. It certainly will allow people to go on to a PhD if they want to, and if they don't want to, they can seek employment after that. And the range of organisations, if it's not directly in a chemical industry related field, and I use chemical industry in the broadest sense. So I mentioned food materials, for example, before. Pharmaceutical industry, could be petrochemicals, it could be all the polymers and plastics. When we think about food, we think about packaging and the issues with packaging and why we need more sustainable packaging solutions so we don't generate the byproduct waste that goes to landfill and causes some of the problems like the plastics in the ocean that I'm sure you've heard about. So there's lots of need for people with these skills that can think in this way. Who's it for and what sort of background do you need? Well, it's clearly got a chemistry focus, so undeniably, but you don't have to have a lot of chemistry to come into this course. So we're really saying that if you've got the equivalent of a first year chemistry background from whatever type of course you've come from, and I've listed there a whole range of, I'm not going to read them through, you can read them for yourself, but most of the courses that I've listed there will have done some chemistry. Obviously, if you've done a major in it, that's a given. Or biochemistry would be pretty well treated as though it was a major in chemistry. But a lot of those other courses have a significant amount of chemistry through them. And it also just enables you to shift direction a little bit if you wanted to get more into this area of green sustainable technologies. One of the things that sometimes people ask about, well, let me just go on to the next slide and just look at the potential where you could work, because this is often where the leading question: where am I going to get a job after I do a course like this? Again, I won't read them all through. There's a whole range of areas, if you like, of where there is opportunity for employment. I was just recently talking to we had a seminar for some of our PhD researchers who are in our, we have a program with industry which focuses around green and sustainable chemistry, where PhD researchers do a project linked to industry. And we were talking to a gentleman who runs a plastic manufacturing company. He's based in Dandenong, not far from Clayton, for those of you that know Melbourne. If you're Melbourne based, you'll probably know where that is. But this person, actually turned out he was a Monash graduate, but he actually volunteered that his company is looking all the time for solutions to overcome the problem of how can you recycle plastics? How can you source the raw materials from renewable sources? How can you minimise the energy cost to run the equipment in the factory? By changing the processes and the ingredients, you can immediately have an impact on many of those things that he was mentioning. And this was a very forward-thinking company boss, if you like, who was really looking to make his industry more green and sustainable. And we've been pleasantly surprised now how many companies are starting to think this way. And you're probably aware that, I mean, if you're in the investment market or thinking about where to invest your money, and people who have superannuation, which some of you may have now, you can have, environmentally ethical superannuation investment and so forth. Again, these are the sort of things that companies want to be able to sell themselves on, and they need people that can help them change what they're doing to move in this direction. Just before I go on to the entry requirements, I just want to make one quick comment. We also have a Master of Environment and Sustainability at Monash, and I'm sure many of you are aware of that. So a question we're often asked is, what is the difference between this course and the Master of Environment and Sustainability? And there is overlap in terms of electives. If you took this course, you would be able to take elective units or subjects from the Master of Environment and Sustainability. But this course will have a focus on chemistry. That's the key difference. The other course doesn't have a focus necessarily on chemistry. It has about 5 specialisations that you can do in different areas around corporate sustainability and more around policy and governance. You will get some of that in this course as well, but it won't be a stronger focus. But you'll certainly be exposed to a lot of those issues. So it will mean you can, if you like, can be coming at some of the issues you might encounter in the workplace from a more technical background approach. Again, Kim, I'll defer to you if I suspect you've been asked this question as well, but I thought I'd throw that up in advance. And as people can also take electives from this new course in the Master Environment and Sustainability, which is also an excellent course. It just depends on what you want and what you're aiming for the future. So as far as entry requirements, I've already indicated that you a first year chemistry equivalent. Now I've said equivalent, it doesn't mean we're going to be looking for, have you passed chemistry 101 and chemistry 102 in first year as the prerequisite. We look at all the backgrounds of people because we know chemistry is out there in many different forms and sizes and names, and we're really more concerned whether you have the right backgrounds to enter at one of these points. And we've got 3 entry levels, 1, 2 and 3. So the 2 years is for somebody who has a tiny bit of chemistry but really needs to boost their chemistry enough to be able to deal with the content and the issues that are going to be raised as we go through the course. And so that's your entry level 1. So you do the course, you need 2 full years to do it. Entry level 2 is for people who've already done a chemistry major or equivalent of what we'd see as a chemistry major, and I've given some examples there. And that would automatically give you 1 semester's credits because effectively you don't need to do any background catch-up subjects, if you like, to give you enough background to launch into the course proper. And entry level 3, so it is possible to do this course or get the master's in 1 year if you've got a chemistry background as well as with an honours degree where you've done a project which we would deem to be in an area of green and sustainable chemistry. And there are some courses out there and people out there that may well have done that depending on where they've come from. And of course, anybody who's coming through, and I don't know if anybody in the audience is a Monash chemistry 3rd year or thinking about doing honours, you would be able to think about the project you do in honours, and if you satisfied the requirement of a green chemistry focused project, you could then set yourself up for getting a full year of credit towards the Masters, which means you could complete the core units of the Masters over 1 year and qualify with a Master's degree. So we've got a fair bit of flexibility in terms of offerings, and I'll welcome any questions people have. I've just given you a broad overview. The way the course is structured, it's divided into parts. This is a very busy slide, so don't try and read it all. There's also actual names of units or subjects. Monash calls subjects units, it's the same thing. Most of these are what we call a 6-point or something you do in 1 semester, and normally a semester of study full-time is 24 points. So you could be doing 4 6-point units, or you could be doing a 12-point unit plus 2 6-point units. That's indicated under Part A, if you can read the Part A there. I know it's a bit small, but that's a compulsory part, core part of the program. Part B is for people who've done not enough chemistry but need a bit more, and a lot of those subjects are actual from our second and third year program. And you'd have to do 6 of those because they're all 6-point subjects. And then there's the Part C and Part D. Now what I'm going to do is go to the next 2 slides because we've got the same information on a bit bigger scale so you can read it. And also there's a comment on this slide about an alternate exit, and we're just about to change that to entry and exit, which means that you can qualify with a graduate certificate of green and sustainable technologies, and that would be equivalent to doing a 1 semester full-time equivalent of study, or in other words, 24 credit points, and you can get a qualification in green chemistry. But again, that we haven't, I can't give you any more details. That generally will be taking some of the core components of the course that are spelt out in Part A and Part C. Let me move to the next slide. So here's Parts A and B. I think I've already covered that. So Part A is compulsory. Everybody would do that, regardless of what your background is. And you'll see that the 24 credit points are subjects that are specifically around green chemistry. You'll note there's what we call a subject we're calling green chemistry consultancy project. That is going to be working with an industry or an organisation where you'll be linked with that company and you'll work on an actual problem or issue and produce a consultancy report, and hence be trained in how to put together a consultancy report for a company. We will be working with the Masters in Environment and Sustainability who have a similar unit or subject, which has been very successful, and we think it'd work very well for this course as well. I don't need to say anything much about Part B. They're background subjects to give you background in chemistry. And then we're moving on to Part C. Part C is another part of the compulsory part. So there are 2 more subjects that you would do later on. They're not going to start until 2022. The Part A ones will be starting next year. And you have the option there of 2 mandatory and 2 units that can be taken from other master's courses. So they could be units in the Master of Environment and Sustainability, or they could be things from the engineering faculty. And there's also a number of other units from the arts faculty that we've identified as being suitable for people doing this course. And then Part D also gives you some flexibility, because there you can do a research project, which is equivalent to 1 semester full-time, 24 points. That can also be split across 2 semesters. So you can you still do 24 points of research, but you don't have to take it all in one lot if you wish. You can split it up across 2 semesters. Or alternatively, you've got sort of 2 12-point subjects. One's an internship, the other one's like a mini project, and then you take some extra electives to make up the requirements for the course. So there's quite a bit of flexibility there in what you can choose and what people might prefer to do. We have quite a few potential partners, and we're only listing, I've only listed a couple here. We also have something I'll just draw your attention to. We have a new training centre called Green Chemistry in Manufacturing. And that's a training centre that Monash leads. It's for PhD training. So it's different to this coursework masters we're talking about. But we have about 20 industries with us in that partnership. It also involves Deakin University, Flinders in South Australia, Curtin in WA. But those organisations, we believe, are very, very keen to take people and have people work with them, for example, on the consultancy project, because they've already committed these companies to green chemistry. That's why they had to pay money to join the centre. So in essence, they have shown their commitment by putting the money up. So we believe we're going to have plenty of enthusiasm to find probable internships and consultancy projects for people if they're interested in doing those units or those subjects in the future. I think I will just about stop there. There's information from our website. There's two websites there. One is the website for the actual course that I've just told you about. The other one that's got the TGCM notation with it is the website for our new centre, Green Chemistry in Manufacturing. And it's still early days with that centre, but as you see that get populated, you'll see that there's webinars and events that have been held that will really give people a nice taste of what green chemistry and industry needs and wants are all about. And please feel free, there's my contact details there. You've obviously got Kim's details for further information, and I'll stop talking and leave it for any questions.